Okay, so in this video, we're going to be talking about arc length in polar coordinates. And to compute arc length in polar coordinates, we're going to remember the arc length formula in parametric form, which was the integral from alpha to beta of square root dx dt squared plus ty dt squared dt. Okay, so when we do this, what we're going to do is we're going to remember our parameterization of polar coordinates. So we can write x as r cosine theta, and we can write y as r sine theta. Okay, remembering that uh, r is a function of theta for all of these. Okay, so let's compute then dx d theta. Okay, dx d theta should be using the product rule. That's dr d theta cosine theta minus r sine theta dy d theta should be equal to dr d theta sine theta plus r cosine theta. Okay, but if we're going to use our parametric form, I'm going to simplify this a little bit and then we'll bring this together at the end. What happens if we add these two derivatives together? The square of these two derivatives together. Okay, this may seem like a mess, but trust me, stick with me. We'll get through this and it's really pretty easy at the end. Okay, so dr d theta cosine theta minus r sine theta squared plus dr d theta sine theta, it's a really bad d theta sine theta plus r cosine theta squared. Okay, we're going to have to FOIL everything out. When we FOIL everything out, we'll get dr d theta squared cosine squared theta. Then we'll get minus 2 times the product of everything, so minus 2r dr d theta cosine theta sine theta plus r squared sine squared theta. Okay, that's just from this. Plus, let's FOIL out the second term. Then we're going to take dr d theta squared sine squared theta plus 2 product of everything, r dr d theta cosine theta sine theta plus r squared cosine squared theta. Now, what we can see here is this mess of things that everything multiplied together is going to cancel out, because we have minus 2 times product of everything plus 2 times the product of everything. Then let's combine like things. By combine like things, I mean let's put everything with a dr d theta together. So dr d theta squared, we're going to get a cosine squared theta plus sine squared theta plus put everything with an r squared theta together, factor it out. Then we get a sine squared theta plus cosine squared theta. Okay, so sine squared theta and cosine squared theta. But we know what sine squared theta plus cosine squared theta is. It's just 1, so this is dr d theta squared plus r squared. Okay, so that was a lot simpler than it looked in the middle. Okay, so if we remember now, going back to our polar parametric form, our parametric form of arc length is going to be integral from alpha to beta, square root, we said dx dt squared plus dy dt squared. dt, that's our parametric form. But if we think about theta as a parameter, this now becomes the integral from alpha to beta of our polar form, which we just computed, should be dr d theta squared plus r squared d theta. Okay, so there's no need to actually convert this to parametric form when we have this nice polar form. Okay, so let's quickly double check this with a nice small example. Okay, so let's find the length of the circle. Example. So this would be to find the circumference of the circle. R equals 3 sine theta. Okay, so remember that this is a circle tangent to the pole of diameter 3. So this distance here should be 3. So the circumference should be pi times d, which should be 3 pi. Okay, so our answer at the end should be 3 pi. Okay, so something that we need to remember is the period of 3 sine theta is actually pi. Okay, so our arc length is going to be the integral from 0 to pi, square root. We need to compute dr d theta. Dr d theta should be 3 cosine theta. So this is going to be, we'll write it like this, dr d theta squared plus r squared d theta. So integral 0 to pi, square root, this should be 9 cosine squared theta plus 9 sine squared theta d theta. Okay, but notice everything's multiplied by 9. So we can factor out a square root of 9, which is 3. And we're left with cosine squared theta plus sine squared theta, which is 1. Square root of 1 is 1. So we are left with this. And this is going to be 3 theta evaluated at 0 and pi. So this is just going to be 3 pi, precisely like we thought it would be. And we'll come back with one more example. Thank you.